Welcome to the Alphalist podcast. I am your host, Toby. Alphalist is a closed community with over 400 CTOs who share their knowledge and experience in a Slack space and at events. With this podcast, we want to give our members and interested parties insights into the thoughts and ideas of top CTOs. If you're interested in becoming a member of the community, please visit alphalist.com to find out more on how to apply. Thanks a lot to our sponsor, the About You Cloud. The About You Cloud offers a full-stack e-commerce solution as a service that runs on exactly the same infrastructure as the About You shop does. It is mobile-first, can act as headless system, event-driven, can be fully localized, and is super integrated into existing solutions. Besides that, it is designed and developed by a really smart CTO and friend of mine, Sebastian Betz. About You has set up a task force for retailers and brands that want to be quick in the COVID situation. This task force will help you with the launch of your shop, as well as with fulfillment, marketing, support, and internationalization. Simply write to hello@aboutyou.com to be supported by this task force. Welcome to the Alphalist podcast. I am your host, Toby, and I'm really looking forward to today's motto. It's scaling to the max. And my guest is John Graham-Cumming, or short JGC, the CTO of Cloudflare. Cloudflare is a publicly listed CDN, or as some might say today, edge computing platform worth, I think, 21 billion euros. And he's working there for 10 years, so I think he's seen everything. Wow. Welcome, John.
Thank you very much for having me on this chat to talk about, it's almost 10 years of Cloudflare.
Almost 10 years. So I guess you've seen a lot, right?
Well, I've seen it go from when 24 people when I joined to, it must be bumping up towards 2,000 now. I'm not sure what the official figure is. So yes, it's grown tremendously, obviously gone from almost no customers to being, as you say, a publicly listed company. So I've seen a lot of that. I've seen a lot of things go well and things not go so well, and real company stuff.
Okay, looking forward to hear more. But first of all, how did you get into computing? What is your nerd path? I'd like to say.
Okay, so you have to realize I have quite a lot of gray hair here that will tell you that I date back to the 8-bit era. And actually, slightly even before that, I, as a single digits child, so something 7, 8 years old, I think I was already fascinated by computers. And this is like 1970s when nobody had a computer at home. And I know I was really interested in how they worked. And actually, my parents sent me to a sort of summer camp thing at Cambridge University where, kids who were very bright could go and just do whatever they felt like doing. And I marched up to somebody and said, "How does a computer work?" And this person turned out to be a professor at Cambridge who sat down, I still remember it quite clearly, with a pad of paper and drew what I now know to be a Turing machine and said, "Here's the theoretical foundation of computing," basically to a 7 or 8 year old. So that was the beginning of it. And then the 8-bit era happened. And we had computers at school, and I eventually had a computer at home. And so I was, self-taught, and then ended up actually studying computer science and mathematics. Okay.
And then you essentially wrote the GNU Make book, as I've seen online.
Well, yeah. So my career has been a number of startup companies. So I accidentally went into startups in 92. So before people really thought about startups as a thing, particularly in the UK, I ended up working at a company in the UK who moved me to Silicon Valley. And so I worked for a bunch of different startups. Some of them disappeared completely. Some of them got bought out for not an exciting amount of money. Some of them became zombies that never will die. One of those companies did stuff around GNU Make. And so I ended up becoming an expert on GNU Make. And so I ended up writing a blog about it, and then that turned into a book. So yes, if you want to know something about how GNU Make works, I'm here to answer your questions.
And do you still practice that, or?
Well, I use Make. Yeah, sure. Sure. I mean, it's the thing is, in my role at Cloudflare, I don't actually write that much code. The other day, I did write, I think, 12 lines of Python, which was pretty exciting for an internal project. But I just don't have time to dedicate to doing a project over a long period. So it's become a little bit more of a management and strategic job than a programming one.
No large dark room with a large dashboard where you see like traffic spikes on an Earth globe and no coding anymore, but just pure management, or?
Well, no, you can see the dark room. I'm sitting in here in Lisbon, which is actually not a dark room. It's fairly light. And I don't have a spinning globe and sort of staring at what's happening, but I can see real-time traffic information for Cloudflare. And of course, Cloudflare has become quite a big bit of running things on the internet. So, and mostly what I'm looking at is problems, not the day-to-day traffic. And we actually publish quite a lot of our traffic data on the web at a thing called Cloudflare Radar. People can go to radar.cloudflare.com and get real-time information about, by country, traffic, attacks, all that kind of stuff. So I definitely do that. But yeah, I mean, my job, when I joined Cloudflare, my title was programmer. I wrote code. I wrote Cloudflare's second original web application firewall, which is just about being deprecated now. It's being rewritten by a team 9 years later. I wrote some compression technology called Railgun. I worked on our DNS server. I mean, I wrote loads and loads of code, basically, and maintained stuff. And obviously wrote for the blog, because Cloudflare blog is very important. But over time, ended up managing people, partly because Lee Holloway, who's the technical founder of Cloudflare, didn't want to be the person in charge of running engineering. And I got asked temporarily about 7 years ago now to take over. So that was a very long temporary job running engineering at Cloudflare.
And is he now working as an individual contributor, or does he also run some sort of an office of a CTO? I recently had Tyler, the CTO of Fastly here. He runs an office of the CTO, which kind of seems to be the thing, right? If you like engineering, to just do that, or what does he do?
Well, unfortunately, Lee became very ill with a brain problem and had to leave the company, and is very unwell, in fact. And so he's not been involved in the running of the company for quite some time. And so we took over all the things he was working on. And because Cloudflare Engineering is now quite a large organization, it doesn't report to me. So it's interesting to think about Cloudflare's structure. For a while, I had engineering and IT and security, basically anything that was technical reported to me. And slowly over time, I gave those things away. So we have a CISO who's running security. We have a VP of engineering who's actually running the engineering team. And then we have my little CTO group, which mostly consists of people doing research. So we work with universities and longer-term projects. But also a small group of sort of staff-level engineers who roam from project to project. We don't call it the office of the CTO because it sounds so pretentious to be like, oh, the office of the CTO. It's just, so we call it the technology team. It's my little team of folks, about 30 people. And so we split. The other thing we do is we created another group, which is called ETI, Emerging Technology and Incubation, which reports to a different head of that group. So we actually have 3 technical leaders in Cloudflare, all of us operating teams that run at slightly different speeds. So you have the core engineering team producing the products, you have ETI doing kind of the internal disruption, next stuff, and you have my team that's working on longer term projects that might be 5 to 10 years out.
And just out of curiosity, what are like the moonshots that you're planning there, like the ones you can talk about?
Well, as a publicly traded company, it's very important not to make sort of forwardly statements about what's going to come next. I think the thing to think about is Cloudflare's network is 200 cities worldwide where we have hardware connected together with the public internet and also with a fiber backbone for some of the major connections that we manage ourselves. And what are we doing? We're bringing security, reliability, privacy, and performance to anything connected to the web and anything connected to the internet. So if you wanted to think about where's Cloudflare going next, it's connect as much stuff to our network as possible. What is the stuff? Well, the stuff is businesses, IoT devices, you and me, people in a coffee shop somewhere. It's try and make those things secure, fast, reliable, and private.
And yeah, if you look at your website and follow your brand, you also see a lot of new stuff that you try. Like, for example, your similar web competitor. I don't think that you guys call it that way, but that you really like expose a lot of data that you also collect publicly. Yeah. Radar, right? I find that kind of interesting. And I think one of the bigger buzzwords in the CDN scene is obviously, and like generally globally, is the buzzword, don't mean it badly, edge computing. Can you tell us a bit more about that?
Well, if you think about Cloudflare itself, you just go back and imagine those 200 cities worldwide with hardware in them running our applications. Those things are the edge. They are the things that are close to end users. And so, one of the ways in which we get good performance is by being near to end users, because despite many years of trying, the speed of light is still the same value. We can't speed it up. And so the only way to do this is to move close to the end user, hence the very large network that we operate. Also, that network allows us to stop things like DDoS attacks where they begin. First, D in DDoS is distributed. If you have a distributed network, you can absorb that around the world. And what are you doing on those machines where you're running, you're running a bunch of code? Now, for many years, it was our code that was running on the edge there. But when you think about the responsiveness of applications, that we've all come, especially with our phones, got used to, I can pick up my phone, I can do a thing, it happens really, really fast. And so how do you achieve that? And, where are the servers that are responding to that? And so one solution is to say, can we move some of that logic as close to the end user as possible? And that's what edge computing is. And so Cloudflare has this thing called Cloudflare Workers, which allows you to write code in JavaScript or in anything that compiles to WASM and deploy it onto those 200 cities worldwide, and then we'll execute the code for you. And that's the edge computing thing. And it sounds like a bit of a crazy thing, but for me, it's going back to the 8-bit world. So the 8-bit world, I could switch on my computer, I could type in some basic code at that time, right? And I could hit run and it would just operate. I didn't have to think about deploying it or compiling it or CI/CD pipelines or any of this kind of stuff. And what I think Workers does and these edge computing platforms is say, write some code, we'll run it, we'll scale it, we'll make sure it's operating, and there it goes. And that's really, for me, is the beauty of it. And if you write code on our platform and you deploy it, it's literally runnable worldwide within seconds. And I've actually done live demos where I've modified code, hit save, flip to a web browser, and hit refresh, and the code is actually executing. So that's really the beauty of it. Is you've got this incredibly fast update time, and it's running everywhere, and you don't have to think about scaling it. It just happens.
Those workers are running in the background then? Those are background jobs or back-end background jobs? Or what is it?
So we use the V8 engine, which is part of Google Chrome and Chromium, and that allows us to run these very, very lightweight processes called isolates, in which we can run our customers' code. And so those things can spin up on demand if they're not. And the beauty of this is that we've actually got it down to the point where there's no startup time at all. Because we have this neat trick, which is that a connection comes in from a web browser to do something, and during the handshake time, the TCP handshake happens, and then there's the TLS handshake where you're actually setting up the crypto parameters. We are able to actually start your code running. So the moment the request actually hits us, bam, we're executing the code. So it's sort of a 0 nanosecond cold start for code, and then we can keep that in memory and execute it obviously over and over again. So it's for that kind of application, it's very much run, on an API call from an application or a website that does something. And then we have these background jobs where you can actually run a thing called Workers Unbound, where we can be running things in the background on our hardware. Batch jobs, perhaps if you want something run regularly, we have a thing called cron triggers that lets you do that. So you can build really quite large applications using it.
And are there any standards on that, or is there any direction the whole industry is heading? I mean, I would say almost every provider got like functions as a service right now, and potentially background jobs. Netlify does that. There are like a few different approaches to that. Are there any standards arising?
There aren't yet, I think. I mean, the obvious standard is people use containers and they say, ship the job. And so if you think about Amazon, you could use Lambda and you could just run something. I think on what we're doing, where it's very, very lightweight, We decided that we would use a thing called the Service Workers API, which is a standardized API built into browsers. And so when you're writing code, you're writing to that API on our edge. That's really our level of standardization. But yeah, you do see things like serverless deployment standards and things like that. But it's not yet the case that we have robust, cross-provider standards for how these things run. We hope the service workers, which is in the browser, is a standard, would be a good way to do this.
And I guess everything is somehow running asynchronously, right? So you don't have I/O problems or those slow code running, or how does it work?
Yes, that's right. We have lots of control over how the thing is running on the edge. In terms of where they're running, what machines they're running in, which thread they're running in, all that kind of stuff. In terms of I/O, obviously, the most common I/O for workers would be making an API call to something else that uses HTTPS, right? So the application does something and maybe it makes an HTTPS call in something else. At which point, obviously, we can put the thing to sleep and wait for that response to come back in again. But the application just doesn't need to know anything about this. This is all entirely transparent.
Okay. And it all sounds a bit crazy and somehow not really connected to reality. Do you have some just real world examples of where it's useful and where people use it, where companies use it potentially?
Yeah, there's lots of companies that use it as a customization layer for Cloudflare, right? There's something they can't do in the UI, so they'll just write some code. And they might say, well, we want to do some complicated geographic redirection logic that Cloudflare doesn't support, so we'll do that. But you're seeing other applications. The folks at Discord have written about this. They've moved a lot of their application into workers. We're seeing people start to break up their applications into sort of 3-tier applications. So a thing that's in the device or the web browser, a thing that's in the back end somewhere in some hosting thing, and then stuff that's actually running in the middle. And the stuff that runs on the edge in that middle portion, it really has sort of aspects of the other two worlds, right? It's secure because only you can update it, unlike code running in the device, which can be messed with. It's very fast to update, a bit like cloud provider, but it's very low latency to the end user. So if you want something that's secure, easy to update, and low latency to the end user, then the edge is a really good place for that. The other thing I think we're starting to see is we have a thing in workers called jurisdictional restrictions, which allows you to say where the code should run. And this is actually really important because one of our views is that although lots of people talk about performance from a serverless perspective and all that kind of stuff, actually we think that compliance with laws around the world is going to turn out to be really important. So, for example, you are a German healthcare company. You provide, let's say, booking services for doctors in Germany. That is something that's highly regulated in the EU and specifically in Germany. And you might say, right, it's great that I can run my application. I built this booking application in workers, but it has to run only in German data centers, right? And the data for those users has to stay in German data centers. So for us, in Frankfurt and in Berlin, etc. Or maybe you are a German company, but not in healthcare, but you say, I want everything running within the EU. So then the code can be run within the EU. And I think one of the huge advantages of having our large network with those many, many cities is that people can divide that up in the way that they feel is right for them, to comply with local laws, to comply with local culture, whatever they need to do in their region. And so actually, I think one of the beauties of the serverless thing is rather than being in, 7 or 8 different availability zones around the world, it's like, okay, I'm going to slice it this way. Maybe I want Germany, Austria, and Switzerland. That's where I'm going to keep the code can run there, the data can run there. And actually, we have some nice tricks in our network where, for example, let's suppose this fictitious German patient has booked a doctor's appointment, has flown to Argentina for a holiday. We used to be able to do that sort of thing, right? Go on holiday places, and suddenly realizes they need to cancel their appointment because they're loving it so much in Buenos Aires, they're going to stay an extra week. It's still the case that their code is running in Germany, and in fact, they would actually connect through our data center in Buenos Aires, and we would say, aha, but this is this particular application which runs only in Germany, and so we wouldn't even do decryption of the crypto stuff in Buenos Aires. The whole connection would get forwarded over to Germany. And so they would get the benefit of they're connecting to a local connection for Cloudflare, but all of the security, all of the data is being held in those locations that the customer chose. So I actually think this application is going to tend to be very, very big for serverless.
You also offer like the typical function as a service stuff, apart from the background jobs and everything, right?
Sure. Yeah. I mean, you can write like a typical worker might be, HTTPS connection to some API, do something. Yes, absolutely. People absolutely do those very lightweight things. I mean, a huge number of our customers do that for some portion of what they're building.
And I saw like just before the podcast that you also have an app store running online. Does it include the whole function as a service and middleware area as well, or is it just front end stuff?
Oh no, you can build. I mean, we actually saw it the other day on Hacker News. I saw there's a company called Zaraz, which has built an entire application running inside Cloudflare workers. That's where it executes. So it's not just like a front end kind of thing. It's really, you build whole applications there. And the App Store was really about deeper integrations with Cloudflare. And absolutely, it could be something that is very back end heavy and not just, a UI modification of some sort.
So it could be something that like receives the request, like a middleware receives the request and decides what to do. Like if it's answered by the normal web server, or if it's answered by the middleware itself, right?
Absolutely. And in many cases, what we're seeing is people say, wait a minute, why do I actually need the backend server? Why don't I just move all this into the edge, right? I need some data storage, which we have through a couple of different things, Workers KV, which is a distributed key value store globally, and a thing called durable objects, which allows you to associate an ID, a user ID, or someone who's logged in with code and data, which will actually move with them around the world. And then you can treat that as a sort of singleton object that you can access for that particular user, and gives you very strong consistency. So, I think people are going to be building, and are building actually, applications within workers entirely without having to worry about having a backend.
And is it also comfortable to build and to debug them? I mean, it sounds as if you have like an awkward web interface where you type in everything and then you save it and you can't version it and so on, or is it?
Well, you have the web interface, and absolutely, most demos use the web interface, but we have this very nice command line tool called Wrangler. Wrangler allows you to do all the deployment of code, all the versioning and everything through the command line. And also through our API as well. So, typically, if people are doing real application development, they'll be using either the command line interface or the API to do that stuff. And Wrangler actually includes a thing called Wrangler Tail, which allows you just to get a live tail log from a running application, see what's happening, debug it live. So, there's a lot of effort gone into the developer experience here, so you can actually debug a real application when it's running.
Interesting stuff, really. I mean, if you didn't get into it, you don't know if that it exists. It's cool. Coming to a different topic, so or maybe there's a bridge to that topic. So can I also use it as a free customer on your platform, or is it
Yes.
Is it a paid feature?
Well, it's a paid feature in the sense that it's something where we do want a credit card, and there are some sort of limits to what you get for free. But absolutely, you can use it as a free customer, and you should try it out. Definitely, it's something where we like most of what Cloudflare does. We want to make it available to the free tier or even just like the very low cost paid tiers, because what we're doing is trying to say that technologies which really at some point were reserved for customers who paid you $1 million a month, really, there's no good reason for that. Their technology inherently gets faster and easier to use over time, so make it available to everybody. So yes, Workers is an important part of that story. Yeah.
You have, I think, 3 million free customers. Is that right?
We have something along those lines. Yeah, about 3.2 million customers and something like 100,000 or a little bit more paying us. Yeah.
The first perspective sounds a bit strange that you have that many free customers and not too many paying customers. Does that strategy make sense? I guess it does, but why?
Yeah. Well, I mean, first of all, if you think about our business is selling a service to people who have put something online, right? It could be their company, it could be a website, it could be an API and stuff like that. There's a few things we want to do here. We want people to be able to try the service out, and the free tier is really important to us. Many of our largest paying customers came to us because someone tried it out for free. The number of times I hear, I'm the CIO of Big Corp, I put my son's blog on Cloudflare, dabbled with it, realized it worked well. I want to talk to you about bigger use of it for our business. I think that's a really important part of getting people to try the product out, market it to them. What we didn't want to be is that enterprise sales company who you've never even tried the technology before you actually buy it, right? It's very much about trying and buying it. The other side of it is when you have such a large number of customers like that who are very, very enthusiastic about the service, you can get them to test things for you. So we'll often go to that customer base or some subset of it and say, there's a new feature coming, there's an improvement, will you try it and give us feedback? If that becomes a huge feedback mechanism and a huge QA mechanism for us. And then it means that the customer who does pay you $1 million a month is getting code that's really been battle hardened. And so that matters a lot. The other side of it is it gives us scale. Right? If you have 3.2 million or whatever the number is, free customers all over the world, then you are seeing all of the internet's problems and speed issues and everything because you're everywhere. And so it's helped us really truly be an international company. Then it's easier to say to one of those big paying customers, yeah, we totally understand the networking situation in Indonesia because you know what, we've got, I don't know how many it is, but let's make it up, 10,000 free customers in Indonesia who we've been servicing, who we've been making sure that stuff operates. So a lot of Cloudflare scale came from those customers, and we really value what they bring to us. They bring us, intelligence about what products we should be building. They're a QA team. They're enthusiastic testers of things. And because of the large amount of data that goes through our network, if there's a new attack that's going to be planned on the internet, often it gets tried out on one of our customers. And so we'll see that new attack and we can learn from that before it impacts someone else.
Talking about attacks, are there any interesting security or hacker anecdotes you can share? You're allowed to share?
Yeah, allowed to share is kind of the interesting side of it. I mean, I'll tell you about 2020 because 2020 has been kind of interesting from a hacking perspective. I think the big trends of the pandemic were an enormous amount of phishing. If you think back to March and April of last year, although it feels like it was 10 years ago, but last year, a lot of people got sent home and had to work from home, and companies had to change how they operated, and people were logging in unfamiliar ways, maybe using a machine they didn't normally use, and that was a rich environment for phishing attacks. Because people could get sent things saying, hey, we've got a new IT system because of COVID, log in here. And obviously at that point, you've given away your username and password. So phishing was massive and continues to be massive. The other side of it is, there was a tremendous increase in internet use. So suddenly jumped up 20, 30, 40, 50%. Where the people are is where the criminals go. Right? So it's the old joke about why do people rob banks? Well, that's where the money is. Well, why do people do cyber attacks? Well, that's because that's where business is. And so we saw a big increase in particularly DDoS, and in particular ransom DDoS, where what would happen is some bit of a company's infrastructure would get knocked offline for 5 minutes, 15 minutes. And we see this in the statistics. The statistics show that there's been a big increase in short-lived DDoS attacks because these are demos. This is how we could hurt you. And then the network administrator gets an email saying, if you don't want that to happen again, pay us this many Bitcoin, right? And that was real. And in fact, in some cases, we've even seen companies get sent in a network diagram by the attacker saying, okay, we've done reconnaissance on your network. If you don't pay us this much, we're going to knock off your VPN concentrators, which are on these IP addresses, to give the attacked company sort of confidence that the bad guys know what they're talking about. So that was the other big thing in 2020, I think, was that ransom DDoS kind of stuff was really quite popular, including many copycats who just sent in a thing saying, we'll knock you offline tomorrow if you don't pay a certain amount of Bitcoin. And in fact, they were just bluffing.
Was there ever a DDoS attack that took you down?
We've had DDoS attacks that have taken little bits of infrastructure offline over the time, but one of the things about Cloudflare is that we have done DDoS mitigation for a very, very long time. And because of the variety of our client base all over the world, usually someone's mad at someone. So there's usually some sort of DDoS attack going on all the time. In fact, if I go into the attack databases, there'll be multiple happening against us all the time. And so we've got really pretty good at defending against them. I don't want to say we're absolutely impenetrable because that would be a ridiculous thing to say, but I do think it's a real center of excellence for us, and also our architecture has made it we're really good at dealing with DDoS attacks across our network.
How do you get good at it?
You you have a wide customer base. You see the attacks coming in. You spend a lot of time doing it manually, and at some point you say, we can't go on doing this stuff manually. We need to automate it. And a large part of our original DDoS infrastructure was written by someone in our Warsaw office who came to me one day and said, I've been looking at all this manual work that's being done. I'm pretty sure I can automate it. And one of the things we did was we built a system which can detect a DDoS attack. And in particular, we're pretty good at fingerprinting the attackers. It turns out that attackers use the same tools over and over again. And so you can actually recognize the fingerprint of their tools and say, oh, yes, that's that particular attack. And internally, all of these attack types are named after different sorts of rum for some reason. So there's all these funny names for them. But over time, you build up this great store of knowledge about how people attack things. The other thing you do, when you have a lot of small customers, quite small DDoS attacks can take them offline, particularly at the HTTP level. And so what you end up doing is building a system that can detect whether the customer is under load. So we'll actually, for our smaller customers, we'll be looking at, they're starting to throw errors. That must be an indication, or maybe an indication, that they're taking the traffic we're seeing, which might be nothing for Cloudflare to deal with. We're doing, 20 million HTTP requests a second. A little WordPress site gets 100 per second, it might fall over. So we're able to detect that and sort of apply back pressure and say, wait a minute, this is actually hurting that particular server. So you just, you know what, we've been doing it 9-10 years. You keep building and building and building and building, and eventually you have a big arsenal of ways to deal with things.
And how much hardware do you have around the world? I mean, it must be a lot, right? You mentioned
thousands and thousands and thousands and thousands of cores. I don't know what the number is, but the key thing for us is the way we think about it is not so much in terms of the number of cores we have or the number of machines we have, but in terms of the number of cities. So it's more than 200 cities worldwide where we have physical hardware that we own and operate. So we don't use the cloud to run it. We are the cloud. So we run that hardware. And our goal is, enough hardware in each of those cities so that we can service the people in that location, right? So we'll be looking at the population, the traffic patterns, and putting the hardware in there, and then bind that all together into a big network.
So to be concrete, I'm in Hamburg. We have 1.8 million people living here. How many servers do you operate here?
I have no idea. It's not. I mean, I can probably find out, but it's not. It's not something I think about a lot. Now, one of the things we do think about is optimization of our software stack, because we'd like to buy the minimum amount of software possible. And one of the interesting things Cloudflare did right from the beginning was ran the whole of our service suite on the same hardware. And so you actually have a single optimization target, because what happens is many companies, they'll have, there's this bit of the network that does WAF, and there's another bit that does DDoS, and there's another bit that does CDN or whatever. And we're like, no, every machine runs the same software stack. And therefore, if one bit starts to get slow or affects another bit, you have to go in and optimize it. And that's made us really efficient about how we use the hardware. We also have a really interesting thing, which is that we keep many generations of hardware in locations. So, we don't just upgrade and throw everything away. And those machines have different performance characteristics. So we have a really cool piece of software called GNU that does real-time monitoring of the load on the machines, can actually distribute work across machines in the data center. So you actually end up with almost exactly the same CPU utilization across different generations of hardware. So we're absolutely using them in the most efficient way possible. So there's a lot of work being done on that side to make the number of machines we have out there is one of those things where I'm like, yeah, I can find it, but it's not what I'm interested in. It's more like, what's my average CPU? What's my median CPU or whatever.
So CPU usage is typically what you look at and what you optimize on?
Yeah. I mean, over the time, we've looked at other things like IOPS, because we do a lot of stuff pulling from SSDs for the CDN side of the business. But we're very much CPU intensive. If you think about things like the WAF, which is doing inspection of traffic, the DDoS mitigation, which is dealing with very high packet rates, The workers product, which is running people's code, is CPU is key. Early on, we did have challenges around DDoS actually with our interrupt handling, because if you go back to the most basic kind of networking, you have an interrupt per packet. Well, you can't do that when you're getting, I don't know, 1 million packets per second or something. So you end up doing clever stuff at the networking side of things. And we use a lot of a thing called XDP, which is Express Data Path in Linux, to avoid that. But yes, CPU is where all the action is.
CPU and SSD then, obviously, right? For the stuff that you store?
Yes. And, SSDs, the real challenge with SSDs there are various challenges, but the real one is wear, right? Because if you're writing a lot of stuff to SSDs, then you do get wear. And, Cloudflare has been very much about using consumer technologies in production. We haven't gone to buy crazy enterprise, whatever that means, hardware. One area where that has not played out well actually is in SSDs. There is a difference between the sort of enterprise or professional SSDs in terms of how they deal with wear and their lifetime compared to some of the very much consumer side of SSDs. So that's an area where we actually a couple of years ago had a big effort to change out a very large number of failing disks worldwide, which is a big effort when you've got 200 cities with hardware in them.
Can imagine. And how do you provision all those nodes, and how do you monitor them?
Yeah, so what we've got good at is one of the things Cloudflare is known for is our blog, which is very public. What we're not known for is our great ability to ship things and get them through customs. So when you deal with 200 cities, 100 countries, or whatever it is, shipping hardware is complicated. And so we actually ship hardware around the world, and it is installed by local techs, right? So we use what are called smart hands in different data centers. And once it is, plugged into our satisfaction, it can then remotely boot, and then we can take over the machine and run it remotely. One amusing story is that if you ship hardware into South Korea, there has to be a manual in Korean that explains how to set it up. And it turned out to be easier for us. So we produced a manual, which was completely unnecessary, on how to set up our hardware in Korean. And actually, for a long time, that manual just shipped wherever it went in the world because we were using the same sort of setup. So, the data center in Paris would receive a bunch of servers, and by the way, there's a manual in Korean.
But you don't run like Kubernetes stuff or anything. It's too bloated, I guess, and you just boot over network, or how does it work?
Yes, it's Pixie boot, and then boot over the network, and then we can download our packages onto those machines. We actually use these trusted platform modules in the machine so that we can sign the software. So we know that it's our software stack that's running on the machine. We know that it's our machine that it's running on. It gives us a lot of assurance of what we're doing. So one of the decisions that Lee made very early on was not to use any form of virtualization at all. So we don't use virtualization on the edge. We actually refer to those machines as the metals because we run on bare metal, basically, no virtualization, run Linux. We do use Kubernetes for other things in some of our data centers where we might be doing like machine learning or big data analysis for our customers and things like that. But on the edge, it's Linux running a bunch of processes, and obviously we use Salt for configuration. We use Prometheus for a bunch of monitoring. We have a whole stack of things to run that thing around the world. And we have a technology called Quicksilver, which we wrote, which is a distributed key value store, which we use for configuration management across the world.
Okay, cool. And is there anything bigger open source components involved in your stack? Like Varnish, for example, would be quite a kind of typical for such a use case, or do you write it all on your own?
No, we didn't write it all on our own. So obviously, the biggest thing is Linux, right? The Linux kernel, all of the stuff that's around Linux. We started out very early on. So the original back end of Cloudflare was Postgres and PHP, right? And the original website, actually, PHP was used for a long time for stuff. And then on the serving side, the original server was Nginx. We used Nginx as a reverse proxy, and we use quite a lot of different instances of Nginx. And over time, there's things we've written in Nginx, there's things we've written ourselves, in particularly in Go and now in Rust. And so it's quite now a mixture of some open source components and a bunch of stuff that we've written ourselves. Another example is that originally we used Power DNS for DNS, so we're one of the biggest DNS providers in the world. Eventually we decided it made sense that we had so much custom logic we wanted that we build our own DNS server in Go. So it's a real mixture of stuff. You mentioned Varnish. Varnish is not something we've used just because we were using Nginx originally. It didn't make sense to use Varnish on top.
Like you mentioned, a lot of technologies that you use. I guess there must be some sort of technical depth in your whole platform and in your company as well. How do you make sure that it keeps on a certain level, and how do you treat it at all?
Well, we recognize that I think that dealing with technical debt is a product of the company, right? So when our engineering team is talking about what's going to get built in a particular quarter, there's a certain amount of it which is that it's like, well, there's this component here which is too old now, it's causing us problems, maintenance issues or whatever. It needs to be replaced and rewritten. There's a certain amount of time going to be assigned to that. So it becomes one of those projects that's part of the decision about what we do in a quarter. And I think in Cloudflare from the very beginning, we've been rewriting stuff, because what happens is if you grow really rapidly, you end up outgrowing the thing you built because you don't anticipate the challenges of where you go. I'll give you a simple example of that. The original Cloudflare was really scaled so that we could have millions of customers with a small number of DNS records per customer. You think about an individual little website with, maybe it's mail server. You'd have 10. Maybe we'd have 100 DNS records, right? And quite early on, we got a single customer who had about 1 million DNS records. And we just hadn't built it to scale that way. Things fell over. So you end up, it's just a fact of life that you get debt. And the good thing in Cloudflare is the relationship between the SVP of engineering and the SVP of product is a very, very close relationship. And they fully understand the challenges each other are dealing with. And so it's never been a problem to say, we're going to rewrite this thing. There's a new thing we're going to, and when we do, we celebrate it. There's a company celebration of, we just turned off this component that was, so many years old. Here's the new thing. This is what it fixed.
The big old thing that JGC has written back then, right?
Well,
it's now gone.
The big thing was getting rid of Matthew Prince, the CEO's code, because he wrote some of the original PHP. So that was all gone. Getting rid of my code, that's happening too. Where there are things that I wrote 9 years ago that I was actually kind of surprised that the WAF survived as long as it did. But I guess it was working, and now it's gone from one person working on it to a team of 10 people or something.
Okay, how do you make sure you work on the right thing?
Part of what we've done in Cloudflare is, I mentioned how we have these different teams with different engineering leads. Part of that is a defense against having to figure out that, right? So we can try different things. So, the engineering team with the product team, they've got a rigorous product management process. They're talking with our customers. They're thinking about what the market is going. They're figuring out what the next features are, what dollars are attached to that. They're off doing that, right? They're doing that kind of stuff. The ETI team is saying, what could disrupt Cloudflare? What are big bets that we might want to work on? Let's go and try those out. And so that team, I'll give you an example. For a while, that team worked on AMP. So Google AMP is technology for, they'd have it in cache and it'd be very, very fast. And we actually had our own implementation, our own cache, because we thought, well, that might be significant for the web. I don't think that's played out very well. But that's sort of part of the game, right? That team was allowed to work on that. They weren't part of the core product team. And the research team that works for me has been doing a bunch of stuff with like Ethereum, distributed web, stuff like that, because we want to understand where that's going. So I think by having these three independent groups, we're able to try things out at different speeds. And that's really helped us, ship at an incredibly high velocity and spot when, things need to be built.
So now I want to visit your crazy lab in Lisbon.
My crazy lab in Lisbon is the one room in my apartment that didn't have anything else in it, and now it's just got me in it. So it's if you can see around me, it's a big mess of of stuff. So.
Okay. So typically in this podcast, I also like to recommend, let's say, nerdy but helpful tools. Sometimes more, sometimes less nerdy. To the people out there. And I typically have those tools that I discover and I just love and tell everyone about them. Do you have any of those? Do you have anything you use yourself to make your life better or to make others' lives better?
Well, it's interesting you talk about this because there are all these different tools that get used out there. And I actually think that email is the most underrated tool out there. And I think people are always searching for a better chat application or some communication thing, blah, blah, blah. And if people would only learn to use email properly, I think the world would be a better place. It's asynchronous. It has threading. It's a really, really wonderful thing. So, I love to look for different email tools. So, at some point I was using Inbox, and right now I'm using Google's Gmail app on my phone. I think email productivity is really key, and in that, keyboard shortcuts. Gmail, you can set up all sorts of keyboard shortcuts. I think those are really, really important in terms of in terms of what you're doing. Apart from that, I'm not like a crazy optimizing everything. I am. My wife would tell you if she was here that I am a crazy person about measuring things. So as you may have seen me drinking, this is my smart bottle, which tells me how much I've drunk. So the one application I'm really looking for, and if someone listens to this has got it, I want to be able to log everything in my life. I want a single log file for my life. And like, how much did I eat? What did I drink? How much do I weigh today? Exercise, all that kind of stuff. So find me that app. That would be the one I would then tell the whole world about.
I think Apple Health Kit is like the foundation for that, right?
Yes. Apple Health Kit is great, and I love the Apple stuff, and have an Apple Watch and all that kind of stuff. And then Apple Fitness Plus has been getting me through the lockdown here in Lisbon. But I'm a maniac for measuring stuff.
But coming back to your recommendation on an email, what do you think about Inbox Zero then?
I try to have Inbox, order 10 maybe. I think that one of the things that you get when I first started working, I got sent on a time management course, literally a thing where I was learned to do time management, and it actually used a filofax, and it used a technique where everything was numbered and you had subcategories and everything was in there and you could figure out anything. And I think all of these things are useful tools, but you shouldn't get obsessed by them. One of the US presidents, and I can't remember which one it is, said about, I think he was talking about the Second World War, but he said, plans are useless, but planning is indispensable. Trying to figure stuff out is really, really important. The actual plan itself will then turn out to be useless because everything will change. I feel the same way about dogmas like, Inbox Zero, which is like, yeah, great. Okay, that's good. I try to keep my email down too, but don't turn it into an obsession.
Yeah, I think I once had David Heinemeier Hansen here in this podcast, the guy who invented Rails and Basecamp and Hey.com. And I think he's pretty right about the fact that you actually give others full control over your life if you just try to live by Inbox Zero. You just give others full control. You just have an open to-do list that everyone can fill with tasks, and what comes in first is then potentially the most important thing in your life. I think the same.
But also I'll get emails where I can respond very quickly. I'll get emails where I can, pass them on to somebody else because they're really someone else. But there are other emails that are, research projects. It's going to take me a while to come up with an answer to it, So what do I do with that? So there's a small number of those that will sit in my inbox and I'll deal with them. I think that's okay, and I think it's healthy to have that. I'm not the person with 1,000 mails in my inbox. I do want to keep it down to a small number.
I still have a little surprise for you. So
go on.
I discovered a small feature in Cloudflare that I think was written by yourself. It somehow stores on your SSD an archived version of our lives years ago. And I now open up Postman, the HTTP client tool, and I fire a GET request to Cloudflare and give it the path /John Graham 2011. And now we see yourself just started working at Cloudflare. And we can now quietly observe you for a while. And you then have the chance to whisper something into young John's ear. What would it be?
Well, I'm not sure this feature exists, but it sounds interesting. I think I would probably say insist on more test suites, insist on more automated testing. The reason I say that was that Lee at the time was running things was he was a little bit, if it runs on my laptop, it runs everywhere. And I think that culture persisted for quite a long time. And I think if I could change something early on, it would be, we're going to have a really nice CI/CD setup. And we're going to run this stuff. We're going to have tests, and I'm going to insist on it. And it was only a bit later that I did that. So I probably would say that to myself.
Okay. Thanks a lot. That's an easy one. Thanks again for being my guest here. I hope we have the chance to at a certain time meet in real life again when this is all over and do another podcast on how you scale in 2021. Thanks a lot, John, and hope to see you soon.
Thank you very much.
Bye-bye. If you want to get in touch with About You and hear more about the About You Cloud, simply write to hello@aboutyou.com. Thanks a lot.